Hi everyone, David from Aberlink here. In this video, we're going to look at the Fulcrum and its use for rapid reverse engineering. The task is, we've been given this laser cut profile from mild steel. We've got absolutely no idea about what it is, no data from it, no engineering drawing, but the task is we need to export this measurement as a DXF, which can then be used for putting into our laser cutter, machine tool, etc. to make copies. So let's see it in action now. So I've sat the part on 2 magnets just to hold it in place, but you can fixture it down if needs be. And we've got the probe switched into scanning mode. That's useful because we can just scan around the outside profile. The first thing we need to do is just measure a plane. So I'm just going to select the plane, tap the stylus on the surface, that begins the scan, constantly move around and then pause when finished. That gives us a projection plane to put the 2D curve data into. So now we select the curve, tell it that we're projecting it into a measured feature, which is this plane that we've just measured, and then we can start scanning. It's the exact same protocol. We tap to start the scan, keep the stylus in constant contact with the surface that you're trying to measure. So we'll start that now. It gathers data points as it's going, so just nice and easy, making sure the stylus is in constant contact with the part you're measuring. This particular part is a gear, so it's like a sprocket, but you could be measuring a slot, a pocket, any freeform profile, and the same principles apply. So once we've finished up the measurement, we pause to finish it. So there we go. So that's nice and clean. Now sometimes if you wobble a little bit on the pause, you might see some data, some obscure points like so. It's very easy to tidy that up in the software. All we do is right click on the point and say erase. We can also right click, erase all in box, and drag a box around if there's a bunch of point clouds. So that cleans the data up. So you'll see that's the curve measurement there. And then all we need to do at this stage is export that as a DXF. So within a couple of clicks, it's a right click on the toolbar, inspection, DXF, export as DXF. And then there's a few different options depending on your parameters and what software you're using to deal with the DXF. But I would recommend exporting measurements as DXF, choosing the XY machine plane because that's the machine plane we're using, and then just give it a name. So I'll just give it a name there. And then you get 3 options: compensated polyline, compensated points, uncompensated points. You can export all 3 and try them out in your particular CAD software or machine tool software, laser cutter software, whatever you're using. I'm going to use compensated polyline. That's the most common option, and that's the DXF exported. So literally within less than a minute, we've scanned and exported a DXF that we can then utilize to reverse engineer that component. So there we go.